Welcome to another deep dive.
Oh, yeah.
Today we're going beyond the textbook with some seriously cutting-edge physics.
Okay.
We've got excerpts from a text discussing a hypothesis put forward by someone named Obidi.
Obidi.
Yeah.
Okay.
And it's a real head-scratcher.
Interesting.
Basically, Obidi is proposing this idea of an entropic force field.
Okay.
And it's causing quite a stir because it might actually address some of Einstein's famous concerns about quantum theory.
Oh, wow.
So buckle up.
Right.
We're about to unpack Obidi's hypothesis.
Okay.
See how it lines up with Einstein's thinking.
Yep.
And explore whether it really could revolutionize our understanding of physics.
I'm excited.
Yeah.
What's fascinating here is how Obidi takes a concept like entropy, which we usually associate with disorder,
right,
and turns it into a potential key to unlocking some of the biggest mysteries in quantum mechanics.
All right, so let's break this down.
Yeah.
Obidi's hypothesis basically says that entropy isn't just some passive tendency toward disorder.
It's an active force.
Okay.
A field that actually guides events at the quantum level. It's like a behind-the-scenes director orchestrating the whole show.
Exactly. Instead of pure randomness driving quantum events like measurement and wave function collapse, Obidi is saying there's this deterministic force field entropy itself.
Whoa.
Pulling the strings.
So this is where my brain starts to melt a little.
Yeah.
So instead of quantum events being totally random, as the traditional Copenhagen interpretation suggests, Obidi is proposing that there's an underlying order, a pattern to the seeming chaos.
That's the core of it. Obidi's hypothesis suggests that events at the quantum level aren't just governed by chance, but by the deterministic principles of entropy. It's a pretty radical departure from how we've traditionally thought about things.
And this ties in directly with Einstein's famous discomfort. With the probabilistic nature of quantum mechanics, right?
Didn't he say something like, God does not play dice?
Yes.
Rejecting the idea of a universe ruled by pure chance.
Einstein always believed in a deterministic universe.
Right.
One where everything has a cause and effect. He felt that quantum mechanics, as it was understood at the time, was incomplete. He believed there had to be some underlying mechanism, some hidden variable that explained the seemingly random behavior of quantum particles.
So could Obidi's hypothesis be the answer Einstein was searching for all those years ago?
It's definitely intriguing.
Okay.
Obidi's model replaces randomness with a deterministic framework driven by entropy. Instead of relying on hidden variables, it proposes that this entropic force field is the underlying order.
Okay.
It's like saying that the universe isn't rolling dice after all.
Wow.
It's playing a strategic game with entropy as the rule book.
So how does this entropic force field actually work? I mean, what are we talking about here?
Think of it.
Is it like some kind of invisible hand pushing particles around?
Like a gravitational field.
Okay.
But instead of pulling objects towards it based on mass, this entropic force field influences events based on entropy. It's like there's this invisible landscape shaping the behavior of quantum particles, guiding them along paths determined by entropic constraints.
Okay. I'm starting to get a picture.
Good.
But how would this entropic force field actually address some of the specific issues Einstein had with quantum mechanics?
Let's start with non-locality.
Yeah, let's start with non-locality.
That whole spooky action at a distance thing.
Right, spooky action at a distance.
Didn't Einstein reject the idea of instantaneous communication between entangled particles?
He did.
Yeah.
It seemed to contradict his theory of relativity.
Yeah.
Which states that nothing can travel faster than light.
Right.
Einstein couldn't reconcile the idea of information being transmitted between entangled particles faster than should be physically possible.
Right. It seemed like those particles were somehow cheating the cosmic speed limit.
Right.
So how does Obidi's hypothesis tackle this paradox?
Yeah, that is it.
Instead of instantaneous action, Obidi's hypothesis suggests that the entropic force field can propagate information and influence events in a structured way, respecting the speed limit of the universe.
So it's not that the entangled particles are communicating instantly.
Right.
They're both being influenced by this overarching entropic field, which ensures their correlation without breaking any cosmic speed limits.
Precisely. It reframes non-local correlations as deterministic effects within this entropic framework, potentially resolving the conflict between quantum mechanics and relativity.
That's amazing.
That's pretty cool.
It's like they're part of a cosmic cosmic dance.
Yeah.
Perfectly synchronized, even when separated by vast distances, all thanks to this invisible hand of entropy guiding their every move.
That's a great analogy.
Yeah.
And it brings us to another point of contention Einstein had with quantum mechanics.
Yeah.
A Copenhagen interpretation.
Right. The idea that the observer plays a crucial role in collapsing the wave function.
Right.
Wasn't Einstein a big believer in an objective reality independent of any observer?
Absolutely. He strongly believed in an objective reality that existed regardless of whether or not someone was observing it. And here again, Obedi's hypothesis offers an intriguing alternative.
Okay.
Instead of the observer collapsing the wave function, it proposes that the entropic force field itself drives that collapse.
So in Obedi's model, it's not our active measurement that forces the particle into a definite state.
Right.
It's this all-pervading entropic force field that's running the show, guiding the process all along.
The observer's role becomes secondary to the fundamental deterministic influence of this entropic field.
Right.
This aligns much more closely with Einstein's vision of an objective, observer-independent reality.
Wow, this is starting to feel like a much more elegant way to understand the universe.
Yeah.
Einstein always believed in a deterministic, causally coherent cosmos.
Okay.
And Obedi's hypothesis seems to be pointing us in that direction.
You're picking up on a key theme here.
Yeah.
Obedi's framework suggests that the universe might be far more orderly and predictable than the traditional interpretations of quantum mechanics would have us believe.
That's pretty mind-blowing when you think about it.
It is mind-boggling.
But before we get too carried away with the theoretical implications, let's try to ground this in something a little more tangible.
Yeah.
Can you give us a concrete example or analogy to help grasp this concept of an entropic force field?
Remember that analogy of entangled particles dancing in sync across vast distances?
I love that one.
Let's take it a step further.
Okay.
Imagine two glows, a left and a right, separated by a vast distance.
Right.
The entropic field would be like an invisible thread connecting them, ensuring they always remain a matching pair, even without any instantaneous communication.
I love that analogy.
Yeah.
So the gloves are like the entangled particles?
Exactly.
And that invisible thread is the entropic field maintaining their connection despite the distance. It's like a cosmic game of quantum dress-up.
Exactly.
Yeah.
It's a way of visualizing how the entropic force field could be responsible for those spooky correlations without needing faster-than-light communication.
So the source material called Obedi's hypothesis, mind-boggling.
Yeah, it is mind-boggling.
What exactly makes this idea so groundbreaking?
Well, it's not just offering a new interpretation of existing concepts.
Okay.
It's proposing a fundamental shift in our understanding of physics by suggesting that entropy is this universal deterministic force. Obedi is potentially resolving some of the deepest mysteries that have baffled physicists for decades. It's not just tweaking the math. It's looking at the very fabric of reality in a completely new way.
It really is remarkable, isn't it?
It is.
This idea that something as seemingly simple as entropy, which we usually associate with disorder, could actually be the driving force behind order and predictability, the most fundamental levels of reality.
It's a beautiful paradox.
It is.
That highlights the importance of questioning our assumptions. And exploring concepts from new perspectives.
Absolutely. And speaking of new perspectives, what does Obedi's hypothesis imply for the future of physics?
Well,
what are the potential implications of this entropic force field for our understanding of the universe?
Well, for starters, it could revolutionize our understanding of quantum mechanics itself.
Okay.
If the entropic force field truly is the driving force behind quantum phenomena, it could lead to new interpretations and potentially even modifications of existing quantum theory. And that's just the tip of the iceberg.
I'm already sensing another deep dive coming on.
I think so.
But I think we've covered a lot of ground in this first part.
Yeah.
Why don't we take a moment to let all this sink in? Okay. And when we come back, we'll delve deeper into those implications and explore what Obedi's hypothesis could mean for our understanding of the universe as a whole.
Sounds good.
Welcome back.
Yes.
We're picking up our deep dive right where we left off, exploring OBD's entropic force field hypothesis and its potential to rewrite the physics textbooks. Before the break, we were just starting to touch on the vast implications this idea could have for our understanding of the universe.
It's truly groundbreaking stuff. One of the most exciting aspects is how this hypothesis might bridge the gap between quantum mechanics and relativity, offering a path toward the unification that Einstein spent so much of his life searching for.
That's huge. Einstein was convinced that there had to be a unified field theory, a way to bring those two seemingly incompatible worlds together. So is OBD suggesting that this entropic force field could be the key to that unification?
It's a tantalizing possibility. Remember, OBD's hypothesis proposes that this force field can propagate information and influence events in a structured way, potentially acting as a kind of field itself. This could provide a way to reconcile the non-locality of quantum mechanics with the finite speed of light dictated by relativity.
So instead of those spooky, instantaneous actions at a distance, we'd have this entropic field acting as a cosmic choreographer, ensuring that everything stays in sync without those faster-than-light shenanigans.
Exactly. It's like an invisible hand guiding the dance of particles across the universe, making sure they move in harmony, even when separated by vast distances.
This is starting to sound less like spooky action and more like a cosmic ballet, with entropy as the conductor.
I like that.
But let's not forget Einstein's deep-seated belief in determinism. Did OBD's hypothesis address that as well?
Absolutely. One of the most profound implications of OBD's framework is that it provides a deterministic basis for all physical events, including those at the quantum level. This essentially means that even the seemingly random outcomes of quantum measurements might be predetermined by the underlying entropic forces at play.
So instead of the universe being a giant casino where everything is up to chance, OBD is suggesting it's more like a perfectly choreographed performance with every step preordained by the laws of entropy.
That's a great way to put it. It's a vision of a universe where even the tiniest quantum events are guided by a grand deterministic order, a concept that would have resonated deeply with Einstein's desire for a causal and comprehensible cosmos.
It's a real shift in perspective to think that something like entropy, which we often associate with disorder and randomness, could actually be the underlying force driving order and predictability at the most fundamental levels of reality.
It's a beautiful paradox, isn't it?
It is.
It really highlights how exploring new perspectives can lead to incredibly profound insights.
Absolutely. Now, we touched on this briefly before the break. But I'd love to dive deeper into the implications OBD's hypothesis could have for the future of physics. It seems like this could have ripple effects across so many different areas.
Definitely. For one thing, if this entropic force field really is the driving force behind quantum phenomena, it could revolutionize our understanding of quantum mechanics itself.
Wow.
Think new interpretations, new theories. Maybe even modifications to existing quantum theory. It's a potential paradigm shift.
Wow. So we could be on the verge of a whole new chapter in physics.
It's certainly possible. And it's not just limited to quantum mechanics. This concept could have massive implications for other areas of physics, like cosmology. Imagine what it could tell us about the origin of the universe, the evolution of galaxies, the large-scale structure of the cosmos.
It's mind-boggling to consider how this one idea, this concept of an entropic force field, could potentially reshape our understanding of everything.
It is pretty amazing.
From the tiniest subatomic particles to the grand expanse of the universe itself.
It speaks to the interconnectedness of it all. How something so fundamental could be weaving together all these seemingly disparate realms of physics.
Exactly. It's like discovering a secret code that unlocks a deeper level of understanding about how everything works. But before we get too lost in the cosmic implications, I think it's important to bring it back down to Earth for a moment. What does all this mean for someone who might not be a physicist, but is simply curious about the nature of reality?
I think the biggest takeaway for anyone, regardless of their scientific background, is that the universe might be far more intricate and interconnected than we ever imagined. This idea that something as seemingly simple as entropy could be shaping everything, from the behavior of subatomic particles to the large-scale structure of the cosmos, is incredibly humbling and awe-inspiring.
It really challenges our perception of randomness and chance.
It does.
It's fascinating to consider that what we perceive as pure luck or coincidence could actually be governed by this deeper level of order and determinism.
Right. And it also underscores the importance of constantly questioning our assumptions and being open to new ways of understanding the world around us.
Yeah.
The pursuit of knowledge is a journey.
Yeah.
And discoveries like Obiti's hypothesis remind us that there's always more to learn and explore.
Speaking of exploring, you mentioned earlier that Obiti's idea could have implications for unifying the fundamental forces of nature.
Yes.
Now, that's a topic I'd love to delve into further.
It's a fascinating area. You see, physicists have long sought to find a single framework that could describe all the forces in the universe. Yeah. Gravity, electromagnetism, the strong and weak nuclear forces. Currently, we have separate theories that work well in their respective domains, but they don't quite mesh seamlessly.
So it's like having different sets of rules for different parts of the universe.
Right.
And they don't always play nicely together.
Precisely. It's been a major challenge to reconcile these different forces under a single theoretical umbrella.
Okay.
But Obiti's hypothesis offers a glimmer of hope.
How so?
Wow.
How could this entropic force field potentially unify those seemingly disparate forces?
Well, if we consider entropy as this fundamental organizing principle, this driving force behind everything, it's not inconceivable that it could also be influencing the interactions between particles that give rise to these different forces.
So instead of 4 separate forces acting independently, they'd all be manifestations of this underlying entropic force field.
That's the idea.
Expressing itself in different ways.
It's like looking at a tapestry woven with different colored threads. Each thread has its own unique properties. But they're all ultimately part of the same fabric, held together by the same underlying structure.
That's a beautiful analogy.
Thanks.
So instead of 4 separate sets of rules, we'd have one grand rule book. Entropy, governing the interactions of all those threads.
Exactly.
Creating the tapestry of the cosmos.
Precisely. It's a vision of a profoundly unified universe. Where everything from the smallest quantum interactions to the largest cosmic structures are ultimately guided by the same fundamental principle.
It's an incredible concept to wrap our heads around, but I think we need to pause here for a moment. And let all these mind-blowing implications sink in.
All right.
When we come back for the final part of our deep dive, I want to explore what Obiti's hypothesis might mean for our understanding of time. The direction of the universe, and perhaps even the meaning of existence itself. Welcome back to the deep dive. We've been on quite a journey today exploring Obiti's hypothesis and its potential to rewrite the rules of physics. We've gone from quantum mechanics to relativity, from entropy to the possibility of a unified theory of everything.
That's right.
Now, for this final part of our deep dive, I want to get philosophical. What might Obiti's ideas mean for our understanding of some of the biggest questions out there?
The big questions.
Time, the fate of the universe, even the meaning of existence itself?
Those are the big ones, aren't they? The questions that have fascinated philosophers and scientists for centuries. And what's so intriguing about Obiti's hypothesis is how it potentially reframes these profound mysteries through the lens of entropy.
So let's start with time. How does Obiti's framework change our understanding of this concept that feels so fundamental to our experience of reality?
Well, traditionally we've viewed time as this linear progression, always moving forward from past to future. But if we consider entropy as this driving force, this organizing principle of the universe, it raises some interesting questions about the nature of time itself.
Could entropy be the engine driving time forward? Is that what creates that sense of a one-way arrow? That constant movement from order to disorder?
It's a compelling thought. Imagine a universe where entropy is not increasing. Where everything is in a state of equilibrium. Would time even exist in such a scenario?
Wow.
Would there be any sense of past, present, or future?
It's almost impossible to picture. It's like trying to imagine a world without cause and effect. without change.
Yeah.
It makes you wonder if time as we experience it is intrinsically linked to this constant increase in entropy.
It certainly suggests a deeper connection between these concepts than we might have previously realized. And if entropy is the driving force behind time, it also has profound implications for the fate of the universe.
That's right. We often talk about the universe expanding, cooling down, eventually reaching a state of maximum entropy.
Right.
A so-called heat death.
The heat death.
But if we view entropy as an active force, as this organizing principle, does that change our understanding of what that end state might look like?
It certainly challenges the traditional picture of a cold, dark, lifeless universe.
Right.
If entropy is actively shaping events, even at the end of the universe as we know it, there's a possibility that new structures, new forms of order might emerge.
So even in the face of ultimate heat death, there might be a potential for something new to arise from the ashes.
It's possible.
It's almost like the universe could experience a kind of rebirth driven by the very force that seemed to be leading to its demise.
It's a fascinating concept, isn't it?
It is.
It's a reminder that even in the face of what we perceive as an ending, there might be potential for transformation and renewal.
Right.
All orchestrated by this fundamental force of entropy.
Wow. This is really making me rethink everything I thought I knew about the universe.
I know, it's pretty amazing.
But there's one more big question I want to touch on.
Okay.
The meaning of existence.
Right.
Does Obidy's hypothesis shed any light on this age-old philosophical puzzle?
That's a question that's likely to be debated for as long as humans exist.
Yeah.
But I think what Obidy's hypothesis offers is a new perspective.
Okay.
A new way of thinking about our place in the grand scheme of things.
So instead of seeing ourselves as isolated beings in a random, chaotic universe, we're part of this grand entropic dance. Intricately connected to everything around us through this fundamental force.
Exactly. It suggests a level of interconnectedness and purpose that we might not have fully appreciated before. If entropy is this guiding force shaping the evolution of the universe and everything in it, then we, as part of that universe, are also part of that unfolding story.
It's a humbling thought, isn't it, to realize that we're not just passive observers.
It is.
But active participants in this grand cosmic ballet orchestrated by entropy.
It really does make you reconsider your place in the universe.
It does.
And it highlights how exploring scientific ideas can lead to profound philosophical insights.
Absolutely. It's been an incredible journey exploring Obidy's hypothesis with you today.
It has been fun.
We've delved into some truly mind-bending concepts. From quantum mechanics to the meaning of existence itself.
Absolutely.
And we've seen how even seemingly abstract scientific ideas can have profound implications for our understanding of the universe and our place within it.
It's pretty amazing.
So to our listeners,
yes,
we encourage you to keep questioning.
Absolutely.
Keep exploring. Keep diving deep into the fascinating world of science and ideas. The pursuit of knowledge is an ongoing adventure.
It is.
And who knows what mind-boggling discoveries await us around the next corner.
That's right.
Perhaps someday we'll unlock the secrets of entropy, time, and the universe itself.
I hope so.
Until then, keep those curious minds engaged and never stop exploring the wonders of existence.
Good advice.
This has been The Deep Dive. Thanks for joining us. Thanks for joining us.